Can we use seawater to solve the world's energy problems? With nuclear fusion, it's possible. Imagine if something the weight of this basketball could release as much energy as 8,000 tons of coal. That's about the same as the Eiffel Tower, and it's how much a coal-fired power plant burns in a day. This form of energy is called nuclear fusion, and it's the same type of reaction that happens in the core of the sun. The fuel for this you can extract from seawater and from lithium, like the batteries that you have in your mobile phone. And those are abundant, and there is enough fuel around for millions of years of CO2-free energy production. So with all these advantages, the question is, why don't we have this already? So one of the biggest challenges that we investigate here at DIFFER, the Dutch Institute for Fundamental Energy Research, is that for fusion energy to occur, fuel has to heat up to a temperature hotter than 10 times the centre of the sun. Then, where that heat hits the wall, it's like applying a blowtorch to the material. And that material then has to withstand this heat for years at a time without problems. And that's what we test with this unique setup. This is the machine Magnum PSI. It's the only machine in the world that can create the heat and the other conditions that you would expect at the wall of a fusion reactor. Here you can see it in operation. One of the things that we investigate is using liquid metals. These have the great property that as the wall is eroded away, it can be continuously replaced. Technology like this can be used in a future power plant, so you don't have to regularly stop and replace the walls. With research like this, we can really make a difference in delivering nuclear fusion as a future resource for humanity. So just think, next time that you're swimming in the sea, you're actually surrounded by the fuel that can power humanity's future.
At DIFFER we are not only doing research on fusion, but we also work on energy storage by clean and sustainable solar fuels. We need new and innovative solutions for sustainable usage of energy, because the world energy demand is increasing while the natural resources that we use currently are decreasing. So we are in a transition at the moment. And at DIFFER we want to contribute to this transition. In the Department of Solar Fuels, we use the solar energy to make a fuel like hydrogen. Hydrogen can be used, for example, to fuel a car. And the fuel can be more easily stored compared to electricity that we gain, for example, from solar cells. Therefore, we can store the solar energy during the day when we have the most sun and in the summer, and store it for the winter and for the evening. Solar fuel technology is not commercial yet because the efficiency is too low. We need to increase the performance. Therefore, we work on new materials and we modify the materials to have a larger surface area, to have more reactions to take place. At the same time, we do operando measurements in order to measure the chemistry directly at the surface. And in simulations, we try to simulate these processes, and then we can compare the simulations with the experiments. My dream is to have sustainable energy solutions available wherever we are, whenever we need it, in the right quantity. I believe that we will need a mix of different technologies for the future, and at DIFFER we try to contribute to this.